Hello everyone, let's take a look at this LeetCode problem, minimum pass cost in a hidden grid. It's a follow-up of LeetCode 1778, shortest pass in a hidden grid. So if you haven't practiced this problem, you can practice it first since they're very similar, except that the cost in each cell in this problem is just one, while in this problem, the cost is different. Okay, so it's an interactive problem. There's a robot in a hidden grid, and we are trying to get it from its starting cell to a target cell in this grid. The grid size is of size m multiply n, and each cell in the grid is either empty or blocked. It's guaranteed that the starting cell and the target cell are different, and neither of them is blocked. So each cell has a cost that we need to pay each time we move to the cell. The starting cell's cost is not applied before the robot moves. So we need to find the minimum total cost to move the robot to a target cell. However, we don't know the grid dimensions of the starting cell, not the target cell. So we are only allowed to ask queries to the grid master object. The grid master class has some functions, like can move function, return true if the robot can move in that direction. Otherwise, it will return false. And move function moves the robot in that direction and returns the cost of moving to that cell. If this move would move the robot to a blocked cell of the grid, the move will be ignored. The robot will remain in the same position, and the function will return -1. Its target function return true if the robot is currently on the target cell, otherwise it will return false. So direction can be represented as UDLR, and our task is to return the minimum total cost to get the robot from its initial starting cell to the target cell. If there is no value pass between the cells, we just return -1. Okay, so that's a problem, and let's take a look at constraints. The dimension can be most 100, so it's not a very big two-dimensional grid. Okay, so what we should do is, since it's a hidden grid, we need to build this hidden grid. So in our main function, first we just define some directions, UDLR. And we mentioned that dimension can be at most 100, so we can just create a larger grid. Here I just initialize to 300 multiplied 300. Then no matter where my starting cell is, I can just define that cell as 150, 150. And in my construct grid function, I will construct this grid. So we have a cost. For the starting cells, we don't care about this cost since it will not applied. So if currently we're in target, we just set this target. Then we just for loops 4 directions. For each new direction, we check this new cell. If this new cell has not been visited, we will try to visit it. I initialize all cell to -1. So at first they're not visited. As long as we visit a cell, like we will set some cost. For example, the cost is 5. We will not visit it again. So if it's -1, we will try to visit it. And if we can move to that new cell, we will try to move to that direction, and we have a cost. Then we will recursively call construct grid function on that new cell and pass its cost, so it can set the cost correctly. Then we need to restore our state. It's very important for DFS function. So for example, for this new cell, if we go up to this new cell, then we need to go down to restore the state. Same for if we go down, then we need to go up. If we cannot move to this new cell, then we know it's blocked. We can just set it to 0. Means this cell is blocked. Okay, so far so good. We constructed our two-dimensional grid. Next, since the weight is different for each cell, so we cannot use a normal BFS. For the shortest path, like we can use a priority queue. We store a pair in the priority queue. The first element is the position. The second element is the count cost. So initially we push the initial position 150, 150, and cost is 0 to our priority queue and mark this position as visited. Then we just do the short pass solution here. While the queue is not empty, we will every time we will try to get the position that has the minimum cost so far in my queue. For that position, if it's target, we can just return it. Otherwise, we will mark it as visited. Then we will try to for loop its 4 directions. For each new direction, if it has not been visited, we will try to visit it. If it has been visited, the value is -1, we will continue. If it's a block, the value is 0, we will continue. Okay, then for this new cell, we just push it to our queue. If there is a pass, there must be a point that we will reach this code path and we can get the correct minimum cost. If there's no pass, finally the queue will be empty and we will just return -1. Okay, that's it. See you next time.